Welcome to Ask and Learn.
All right. So for this problem, we have the LRC circuit, and the current is given by the small I, and the amplitude for the voltage amplitude for the resistor, inductor, the capacitor given VR, VL, and VC. So for the part A, I want to show that the instantaneous power into the resistor is PR. So because for the resistor, there is no phase difference between the voltage and the current. So in that case, the VR simply equal to IR times cosine omega t. So basically, it is proportional to cosine omega t. So the power, instantaneous power, will be equal to I times VR, which equal to VR I cosine squared omega t. And then you utilize the triangular function relation, and you will see that this is equal to times I times half and cosine 2 omega t plus 1. Okay, and then if you try to do the average over time, you'll see that this term, the average of first term over time is actually 0, because this is oscillating and the mean value is 0, right? So the average is 0. So the residue will be the mean the average value of the power, which will be equal to half VR I half of VRI. Yeah, that's it. So that is the power. So this is PR. Okay. And for part B, so we want to find out the instantaneous power for the inductor. Because we know for the inductor, the voltage leads the current. In that case, VL in this case will be equal to the small I, which is I times cosine. No, it's not I times cosine in this case. So firstly, let's figure out the amplitude, which is I times omega L. Because the voltage leads the current, so it will be cosine omega t plus pi over 2. So pi over 2 is the leading phase. Okay. And if you simplify this equation, you'll see that this is equal to negative I omega L sine omega t. Or you can say that this is equal to negative VL times sine omega t. So this VL is the amplitude. And the power, the instantaneous power on the inductor will be equal to VL times I, small I. So equal to negative half VL times I times, just utilize the triangular function relation directly. So equal to this one. Oops. Okay. And if you try to do average on this expression, you'll see that this is 0. So the same reason, the sine 2 omega t is also oscillating function, and the average value is just 0. So the average value is 0. So average PL is 0. And for part C, it's a similar stuff, but so VC in this case, VC will be equal to VC times sine omega t. Because for the capacitor, this will be a minus pi over 2, okay? So this will become sine omega t. And then, so similarly, you can express the PC as half VC I times sine 2 omega t. So you can easily see that the average of PC is 0. Okay. And for part D, so the instantaneous power delivered by the source is shown in section 31.4 to be P equal to this step. Show that this equal to rho at each instantaneous time. So this is very straightforward. You just need to sum all of them together. You just need to add this term, this term, and this term. Just add all of them together. And yeah, and then you will see that this is equal to this expression. Okay. Now add this. So firstly this term, and this term, and this term. Okay. Yeah.